Hi there, welcome back to Triplicate, and we are going to move on with our radical synth, the Heresy, and we're going to do some further work on its user interface. We got this working with our PCBs with long zigzag tracks. There were two issues. Firstly, you have to press quite hard to get it to sound, because this black stuff is actually 0.5 millimeter thick plastic. So we need to address that. And secondly was the calibration. So you calibrate it here and here and it's absolutely fine, but you try it here in the middle and it's half a semitone out. And that's weird, because this is just a zigzag track. Surely it's exactly the same thickness and what have you all the way up. So we will first look at that. Okay then, let's fire this up. Okay, so let us calibrate our top string. There's it working, and I've got a ruler here. I'm going to use the edge of the ruler and I've marked those are the calibration points. So we are going to put our ruler there, and this is how we calibrate that. We press low and we get 123.123 yada yada. That's with the A to D maximum is 1.0, and we're going to calibrate the high point here again. So that's 50 and that's 80, so that is in the middle, it's 66. So if we put our ruler there and we look at there, we get 65.2 something. Or it should be 66. So let's see if we can. So it's nearly a semitone out. Let's see. It's the best part of a semitone out. So that's our problem. Let's see why it's doing it. Okay, so to investigate this, I'm going to leave this in place for now and use my test one, because I had 5 of these boards made, and that is the 5th, which I set up to test mounting it and using it. So I have to take this jobby wiring stuff here and so I'll wire it onto there or break into these, I don't know. I shall see. Anyway, I will do that off camera, because it's just me wiring up. So, let's get this. Oh, but in the meantime, in the meantime, I think we are going to pull this off. Oh, okay. So we can actually put contacts directly down on the wire along the track here. Okay, so I've taken the normal wiring for the strings off and made an extra little bit of wiring just to this test board, and I've taped down a ruler so I know where I am, and I've just gone up every 10 centimeters for the first half and 1 centimeter for the end, and you just put the meter on there, and 154.7, 1.59587, etc. And I've taken a bunch of readings and not filmed them because you do not want to watch me taking readings and basically getting my head in the way of what I'm doing anyway. So, okay, and I've plotted out the results here, and the blue points and lines are what I've actually measured, and the orange ones are what would happen if it was linear, up to 300 millimeters. Yeah, it's not linear. How can that be? It's a track on a PCB. Maybe the track is thinner? Yeah, if the track was thinner, the resistance would be higher and the voltage would go up quicker for the same current. So maybe that's it. The tolerance, manufacturing tolerance, is on such a long run of track as such that it's thinner at the top. So I am now going to try and check the ones that are on the string assembly and see if they behave, that they are the same. I mean, I suspect that, well, I know they're going to be non-linear because the thing's out of tune. So let's look at that. Okay, so back on the connected up the normal strings, and we are going to start the software like that. Okay, and down at the bottom here we've got 4 buttons which print out the raw A to D value, well, normalised to 1, for the strings. String 1 seems to be a bit erratic sometimes. Another problem to sort out. We're going to try string 2. So if I, again with my ruler so I know where it is, hit 2, I get that. And I'm going to go in two semitones at a time, and you can see it's printing out a value there, so I can just dump this list of values into a spreadsheet, and I can use the video to check that I have got all the points I thought I have. I missed one or gone a semitone instead of the whole tone. And that's your lot. Okay, let's put those in my spreadsheet and see what we get. Okay, so here it is. I've plotted it out. So the orange line is says ideal. That's the one that's calibrated to the ends, assuming the ends are good. The blue line is measured, and you can see it's not linear, and the yellow is the error between the two, which is zeroed at 0.4 and 10 times, just scaled to fit on the graph. And I also did string 1, string 3 and string 4, where the error goes the other way. Worked that one out. And they are all non-linear to some extent, so we're going to have to fix this. I don't know what's causing it. Maybe because it's a long thin track, the tolerances on the PCB etching are not consistent, so the track's width varies slightly, or maybe the hassle, the solder plating, it varies in thickness and is enough to change the resistivity of the line, the track. Anyway, for now we're going to have to live with it, so I am going to come up with some scheme of calibrating it. Okay, so what I have decided to do is simply calibrate each string at each semitone point, then we know they're going to be in tune, and linear between them, which will be near enough. So let's fire this up. Okay, so here we have start calibration for each string, and then we have an abort and a print, and if we print, it's just a default calibration. You notice it's printed for string 3, it's printed 1 for every note going up. Okay, so we are going to start calibration for, shall we say, string 3? 3. Right, and it asks me to calibrate C1, which is that. And we see we get a reading, and then it asks me to calibrate C sharp 1, which is that, and it asks me to calibrate D. Okay, so let's fire this up. Alright, let's calibrate string 4, shall we? So, we start calibration and it tells us to calibrate C1, so we press C1, we're getting a nice input, and then it tells us to calibrate C sharp 1, and then it tells us to calibrate D1, that has not worked. Try again. That's good. D sharp 1, E1, F1, F sharp 1, G1, oh no, and I've got it wrong. Saying I should be up to O, because... So now I abort. Right, so here we are nearly at the end. It's asking me for A sharp 3, which is that guy. And you can't currently go back, so if I get it wrong here, I'm going to start at the start again. So a bit of a... And B3, accept new calibration, yes. So I am now going to do the other 3, because I've started and aborted them all and what have you, and then we'll see if it actually plays in tune. Okay, well, I have managed to calibrate them all after a fight mostly with the software, because it was hastily written and reasonably buggy. So yeah, it's now kind of in tune. So yeah, I can... And it kind of works, and you can do a 3-note chord. There we go, one major chord, and I can't do all 4 at once easily because my hands aren't big enough because they're too far apart. I've also got the new sound engine working. Which I admit isn't going to set the world alight. However, it's work in progress and we will come back to that. So it's taken me quite a long time to get here because having decided I had to do this calibration of every semitone point, it then took me quite a while to get the software to do what I wanted it to do. So I am going to call it for this video here, and in the next video we will look into the problem of having to push really quite hard on here to get the thing to sound, to register the note. And I know I was going to do it in this video, but I've spent enough time on this video, so I'll do it in the next video. So until then, it is goodbye from Triplicate.
Goodbye.